Hello student. In this video lecture I am going to explain how to obtain the mode of the binomial distribution. We know that mode is the value of the random variable at which probability mass function is maximum. That is, if m is the mode, then the PMF increases up to m, then further decreases. If probability mass function is increasing, then the ratio P of x upon P of x minus 1 should be greater than 1, and if the probability mass function is decreasing, then this ratio should be less than 1. If we are given the probability distribution of random variable x, suppose random variable x takes values 1, 2, 3, 4, 5 with corresponding probabilities are 0.1, 0.2, 0.3, 0.2, 0.2. Then the mode of this probability distribution is the value of the random variable x corresponding to the maximum probability. Here maximum probability is 0.3 and corresponding value of random variable is 3. Therefore mode is the 3. Okay, in this way we can obtain the mode of the given probability distribution. Now how to obtain mode of binomial distribution? If x follows binomial distribution with parameters n and p, then if x follows binomial distribution with parameters n and p, then we know that probability of x plus 1 upon p of x, which is equal to n minus x upon x plus 1 into p by q. Here x takes values 0, 1, 2 up to n minus 1. Suppose this is equation 1. Then using this equation we can write p of x upon p of x minus 1. This ratio is equal to n minus in bracket x minus 1 upon x into p by q. Then we add 1 and we subtract 1 from this term, then this term remains constant, which is equal to n minus in bracket x minus 1, this bracket complete, upon x into p by q minus 1 plus 1. We make adjustment in this term. Now this can be further simplified as follows. This ratio p of x upon p of x minus 1 is equal to n minus in bracket x minus 1 into p minus x into q upon x into q plus 1. And further, after simplifying this, we have n into p minus x into p plus p minus x into q upon x into q plus 1. Okay, Then we make some adjustment here and we take minus x common from these two terms, minus x into p and minus x into q. Then we have n into p plus p minus the minus x is taken common. Then remaining term in bracket p plus q is the remaining term upon x into q plus 1. Then we know that the total probability p plus q is equal to 1. Then we have from these two terms take p common, then the n plus 1 into p minus x upon x into q plus 1. Suppose this is equation 2. Now from this equation 2 we observe that this ratio p of x upon p of x minus 1, this is greater than 1 if x is less than n plus 1 into p, and this ratio less than 1 if x is greater than n plus 1 into p, and this ratio is equal to 1 if x is equal to n plus 1 into p. Okay, thus in this case the probability mass function increases up to n plus 1 into p and further decreases. Now we see two cases of the mode of the binomial distribution. First case is the if this term n plus 1 into p is not integer, and second case is the n plus 1 into p is an integer. In that case, how to obtain mode of the binomial distribution? Now first we consider the first case. First case, if n plus 1 into p is not an integer. Okay, if n plus 1 into p is not an integer, in that case mode m is equal to box n plus 1 into p. Here this box A is means the meaning of box A is the only integral part of A, that is if box 2.3 is equal to 2 or box 3.8 is equal to 3. In this case we take only integral part of this value. Okay, in this way the mode of the binomial distribution is obtained if n plus 1 into p is not an integer. This is the first case. Then the second case, if n plus 1 into p is an integer. Case number 2, if n plus 1 into p is an integer, then in this case ratio p of x upon p of x minus 1, this ratio is equal to 1. Therefore probability of x is equal to probability of x minus 1. Now in this case both probabilities p of x and p of x minus 1 are maximum. Hence in this case there are two more exist for the given probability distribution or for the binomial distribution. Hence, in this case, value of the mode is not unique. We have two modes, therefore it is called as the bimodal distribution. Suppose X follows binomial distribution with parameters 7 and 1/2, then values of n plus 1 into p and n plus 1 into p minus 1. N plus 1 into p is equal to, that is 8 divided by 2, and here 8 divided by 2 minus 1, that is 4 and 3. In this case 3 and 4, these both are the modal values. Okay, then suppose if X follows binomial distribution with parameters 8 and 1/2, then the modal value is n plus 1 into p only, and which is equal to 8 plus 1 into 1/2, that is 9 by 2, which is equal to 4.5, which is equal to 4. Okay, in this case the n plus 1 into p is not an integer, therefore we take only integral part of this value, and which is equal to 4. Okay, and if n plus 1 into p is an integer, in that case there are two more exist, n plus 1 into p and n plus 1 into p minus 1, and these both values are the modal values, which is called as the biomodal. Okay, in this case mode is not unique. In this way we can obtain mode of the binomial distribution. Thank you.